Okay, welcome back to our channel. Today we are diving into the fascinating world of civil engineering. So, as we explore the working sequence for the construction of board piles. So, this is our concern today. What do we mean by board piles, which are also known as drilled shafts, are type of deep foundation elements used to support structures. They are typically employed in areas with weak soil condition, which will provide stability and strength for the structure that we are going to build on. So, uh, generally, let's see first what will be the working sequence for the construction of board piles with temporary casing. Uh, Most of the time, we start by preparing for the work. We begin with the preparation work. This involves site assessment and determining the necessary equipment and materials. The second thing is we're going to do is driving a temporary casing. We drive a temporary casing into the ground to protect the borehole and maintain stability during the boring process, because if we have a weak soil, the weak soil may cave in or collapse while we are doing the piling work. The third segment is doing a boring work. Now we move on to boring. Specialized drilling equipment is used to excavate the soil to the required depths. And then in the first step, what we are going to do is cleaning of the base. After boring, it's crucial to clean the base of the borehole to remove any debris and ensure a solid foundation for the pipe. Next is prepare our reinforcement cage so that and install the reinforcement cage inside the board, and then the sixth step is board pile concreting. Once the cage is in place, we proceed to board pile concreting, where concrete is poured to form the pile. The seventh step is extracting temporary casing. This is after concrete sets, we extract the temporary casing, leaving the pile in a position. And the eighth step is check the tolerance of the board pile to ensure it meets design specifications. And the ninth step is we dispose the excavated materials from the site and according to environmental regulations. Board pile recording is a 10th step, which is very essential. So we record all details of the board pile construction for the future reference. And the last thing that we are going to do is pile testing. We are going to conduct pile testing to verify that the load bearing capacity and the integrity of the piles is in safe hands. So after this, let's see step by step uh, how we are going to achieve our goal. The first thing that we are going to do is demarcation of the pile location. So first, a careful site survey is conducted. Let's take an example of this figure. What we are going to do is we are going to have such kind of a site that needs to be conducted for the pile location according to the shop drawing. So you may have such kind of drawing. For example, this is a single pile drawing. So as you can see, they have what center to center dimension for the piles. And then what we are going to do is, for example, if we have this pile, what we are going to do is we need to make specific pointers so that we can have a demarcation. For example, we can have like 4 pegs besides the pile, and at the center of the pile we're gonna have what? A single peg. Once the locations are confirmed, we fix the center of each pile by driving a steel pin into the ground. A red identification ribbon or a painted red color is then tied to the top of this pin for easy visibility. So that the next thing that what we are going to do is we need to have reference points which are established at least 2 meters from the pile center, which is drawn in orthogonal direction like this. like this, like this, like this, so that we can have a reference point for our pile. This is our pile, which is circled in dark lines. Okay. After let's see together. After marking, what we are going to do is, after making the reference pointers, we align the rock and soil auger with the center of the pile location, and then start our excavation work. As you can see here in this figure, we have what? We have here the reference pointers, and then the reference pointers at this point. Here, the pile engineer is showing how the center of the pile is located at a given pile name, with date also. And then with everything in place, pre-drilling of the borehole can now commence. So that pre-drilling can commence. Here you can see this is the peg, which is away from the center around how much? 2 meters. This is the center of our pile. Then what we are going to do is, with everything in place, pre-drilling of the borehole can commence, like in the figure here. So pre-drilling may commence here. So this is the starting point. Afterwards, what we are going to do is positioning of our equipment. One set of piling equipment to be used for piling will be positioned near the pile location to be constructed. So before any drilling begins, all foundation excavation must be completed. This preparation is vital for ensuring a stable and safe environment for the board piles and the foundation piles. Finally, what we are going to do is, we are going to check the verticality. We must check the mast, what we call the drilling rig, for verticality, ensuring that the rig is vertically accurately is stated at a given point, so that it may not affect the integrity of the pile construction. So here it is figuratively shown. So after doing this, after commencing like excavating around 3, 4, or 5 meters, if the soil is weak soil, what we need to do is, we need to install a temporary casing. So it is essential to support what? The overdone soil above the hard strata to prevent collapse during drilling. This ensures a safe and efficient drilling environment, so that we guide the rig throughout the drilling process, so we have a proper alignment to maintain the integrity of the borehole. This temporary casing must be of a stable construction to avoid any loss of shape or distortion during installation. So this stability is vital for effective drilling. As you can see in this figure, these are what we call our casing. That is going to be used for the integrity. So this is all about the preparation work until we check also the total length. For example, from starting point up to, I don't know if you can see, this is totally 3 meters in length, and we have also, with some tolerance, our diameter should be fixed for the what we call casing, Okay, this is all about the casing. And then here, as you can see here, this is the mast, or what we call the rig machine. At the bottom of the rig machine, we always check our center is in good hands. This is the bottom of our mast. And then we attach our boring teeth to the machine, so that we can bore and excavate our pile. So these are what we call different casing dimensions for different piles. So we are going to commence and excavate. Before we do that, we need also to remember that we need also to have the data from the geotechnical investigation on the soil property with respect to depths. For example, around near to the pile excavation, we have a borehole data starting from 1 meter up to here. This needs to be also withdrawn from this, and put up to depths of 28 to 30 meters. 28 up to 30 meters. It shows when we are commencing or doing the excavation work, we are going to read also the geotechnical investigation report. The geotechnical investigation report. Okay, this is how we commence the excavation work. This is how the total configuration of the site looks like. Here we have reinforcement cage preparation area. This is the rig machine. So this is the way how we are doing our work. So this is the sample, as you can see, and then this is the excavation procedure. This is the excavation procedure, so that we need to keep our site also safe, that the peoples, or the working people, should not just uh, interfere with the work, so that they can have to have a safety factor, so that we need to put these lines. And then this is how the excavation commences. As you can see in this figure, this is the starting point of our excavation. This is how the machine acts. So once we have done that, the excavated soil will be withdrawn from the borehole, like this condition, and then our work continues. How this is the casing, as we have previously discussed. This is the casing that we are going to insert for what? For general excavation, because the soil may collapse in or cave in. So that to protect the topsoil due to the overburden pressure, we should have to have the casing that needs to support the horizontal load from the surrounding of the soil up to only 3 meters. Afterwards, we have other mechanisms. We are going to use slurry materials, or what we call bentonite chemicals, so that. Okay, next, that what we are going to see is about the drilling fluid, or what we call the stabilization unit. So this drilling fluid, most of the time we use a bentonite type of fluid. So we need to check these important things. The first thing that we need to check is the density of our viscous material, or the fluid. We call it the bentonite slurry. And then we need to check also the pH of that slurry. That needs to be monitored frequently and adjusted when necessary to maintain the required quality of the slurry. So the operation of this recycled through a descending unit, the next thing that we're going to see in the figure. And then this, the soil stabilization raw material, shall be mixed with fresh water, so the pH value can be in correct manner. So the slurry must be also tested during the drilling to establish a consistent working pattern. So prior to placing concrete in bore pile, slurry samples will be taken from the bottom and at the interval not exceeding 3 meters for the full height of the slurry. Now, after saying this, how are we going to prepare? How are we going to configure this slurry material is very important. So let us see next, how are we going to prepare? Let's see two different approaches. The first one here, it shows, the first one here, it shows how the slurry material is not used. So without any slurry material, how the pile is going to react. As you can see, this is a soil sample, and then we inserted our pile, and then we dewater, and we are going to see the hole. So what we are going to do is put a reinforcement inside here, but as you can see in the figure, the soil already collapses or cave in, so we cannot get the board excavated soil stratum here. So in the next video, we are going to use a slurry material. So As you can see, this is a slurry material at the top, and then this is the pile, and then what we are going to do is pour out all or pump out all the slurry material from the soil stratum, so that the sides of the board pile should have kept their own shape, so that we can do the piling concrete and reinforcement caging. As you can see in the figure, it is clear. So saying this, what you need to remember is that the chemical that we are going to use is called bentonite, or the ingredient that we are going to use is bentonite, which is a fine-grained clay primarily composed of montmorillonite. There are two types commonly used, the sodium-based and the calcium-based, but the sodium-based bentonite is essential for soil stabilization in the piling work. When mixed with water, it forms a slurry. So that it stabilizes the sides of the pile borehole. This is crucial to prevent the soil collapse before and during the concrete pouring. If the borehole wall collapses, loose soil can compromise the pile's quality and lower bearing capacity. So that the sodium-based bentonite works effectively because it swells in the water, forming a stable double layer on the soil particles. This property maintains slurry consistency, adapting from gel to fluid under disturbance. So how are we going to test this on site? We use two test types. What we are going to test is the first is what we are going to use is a density test here, a density test, so that we have a proper mix ratio, a proper mix ratio. As you see in this figure, we have here a slurry material, so that we put in here in the density and then check the density of this slurry material, and then if it passes through the required quality, then we're gonna pass through the next test. The next test is pH test. So as you can see, the pH test should pass through a colored standard, so starting from 7 up to 14, we're gonna have like a pH value variation. So based on the color indication, we're gonna select the proper type of mix ratio. So as you can see in this figure, this is the color that we have got, so that the pH value indicates a passing mark, so that we can continue doing our boring work. So that, and then this is what we call the stabilization unit, or how the mechanism works. Obviously, the thing is we are going to mix our slurry material or the bentonite using stage 1 here on the tank or stabilization unit. After mixing, we pump out this into what we call the board pile system. So as you can see, this is the casing. This is the casing. Bottom of the casing, this is what we call the soil layer. The soil layer. So it doesn't have any kind of casing, so that we need to protect this wall. So that in order to protect this wall, we need to use a chemical called the slurry chemical. So this is the slurry chemical. This is the slurry chemical, so that we pump in the slurry chemical, and for the reuse, we prepare a site excavated near to the piling, this one, and then this will be collecting, pumping out, collecting, and then this collected will be again recycled or taken back to the stabilization unit here, so we can reuse our chemical again. So before we reuse, we need to check the pH and also the density, and there is also other uh, methods that we can test on the site, so that this is very crucial and important. We also prepare the septic tank to manage and mix the slurry. After excavating a temporary storage near the board pile, recycle the slurry and transfer it back into the mixing septic tank to process for reuse. So before pouring concrete, we ensure the slurry is at the proper mix ratio by conducting density and pH tests, along with other testing methods. Finally, we apply the slurry into the borehole to prevent soil collapse, which can compromise the pile's strength. This is where we apply our slurry material. So proper configuration of this bentonite ensures a strong foundation system. Okay, next is once the drilling reaches the required toe level, we use a flat bottom cleaning bucket. This is the bucket. So cleaning continues until the material extracted from the bucket is pure water and slurry, so that we don't have a disturbed toe level. So to ensure a clear borehole, vital for the integrity of the piling process. Saying this, the sequence of bore piling construction using the stabilization liquid looks like this one. As you can see here, we have 5 configured steps, the simple steps. The first step is existing soil will be excavated using a drilling rig, and then in the next step, a slurry tube here, as you can see, a slurry tube is what inserted into the borehole to maintain the stability, so that what the side of the wall of the soil cannot be collapsed or cannot be caving, so that it can create integrity problem on the pile. The third step is reinforcing steel cage. This is the reinforced steel cage. Steel cage is what? Carefully placed into the trench. Carefully placed into the trench. And then finally, the fourth step is concrete is poured into the borehole. As you can see here, using a funnel system, the concrete is placed into the borehole, and then ensuring a strong foundation, pile foundation. And finally, what we have is a slurry that is going to be removed out through what? A process. When we insert the concrete in, the slurry material will go out. So this slurry material will go out to the stabilization unit. Stabilization unit to be reused for the another pile. And then finally, the slurry will be removed, revealing the complete reinforced concrete what? Pile in step 5. This is what we call the finished product for our board pile. So in order to achieve these steps, in the middle, what we need to conduct is a Koden test. What is a Koden test? The Koden is an instrument or a device utilizes ultrasonic distance measurement to assess the shape and the deviation of the borehole and the slurry trench. So by performing the Koden test, we verify the verticality of the pile and the bailout size. Bailout size means if we have such kind of thing, like if you are boring for a pier foundation system, you can have a bailout at the bottom, so that you can have a good bearing stratum, or what will strong bearing stratum. So this Koden test measures accurately the verticality of the pile and the bailout size, ensuring structural integrity, so that this Koden test is crucial to do for inside testing. So the steps are obviously listed here. The purpose is obviously to observe verticality and the dimension of drill hole of the board pile, and also to investigate the wall surface, and also to check if there will be nicking or bulging out of this pile below the depths of the ground. So that what we need to do is we insert ultrasonic instrument until what? The bottom of the pile, so that it can tell us how is the side of the wall shaped. Generally, the test procedure is a crane is used to mobilize the winch to the center of the pile excavation, and then we connect the winch and record through the 15-pin connecting cable. This is obviously the instrument, and then we connect a 220 volt AC power supply and turn on the recorder, and then input related data of the borehole, turn on the system and lower down the sensor for testing. Then testing results shall be automatically printed on a special paper on site. The quality of excavated shaft for bore piles are accepted when the verticality is within what? 1 to 100 of its length. For example, we accept the quality of excavated shaft when the verticality is 1 to 100. When we say 1 to 100, let's say if the pile is 10 meter in the length, then the allowable deviation in verticality would be how much? would be 1/100 of our 10-meter depth in length of the pile. This will give us around, in centimeter, it will be around 10 centimeters. So that this is the maximum allowable deviation in verticality. So this ensures the structural integrity and the performance of our board pile. So let us obviously see some. This is how the machine works. This is obviously the bentonite chemical here. The bentonite chemical here inserted into the ground so that it can protect this wall of the soil. This is, as you can see, a clay material so that it may easily collapse. So the shape can be what? The shape can be damaged. So that in order to protect this shape, you need to use this bentonite chemical. Okay? And then this is what we call the Koden test, in the Koden test monitor that is connected to the testing instrument. So to summarize, inside, then the next So this is the ultrasonic side wall recording. So we call it a Koden test. Next is we prepare after drilling. We meticulously check and verify the borehole depths against the daily piling sequence and the pile data. This ensures accuracy in our operations. Next, we establish a reference site datum level. This is crucial for positioning the reinforcement cage correctly concerning the cutoff level. So our skilled steel fixers then prepare the reinforcement cages according to the specification in the drawing. So this is obviously on-site prepared cage, as you see in the figure. Finally, the reinforcement segments are connected by lapping and securely fixed together using binding wires and cage welders. Sometimes not only binding wires, but welding can be applied for strong bondage between the reinforced bars. These steps are essential for ensuring what? The structural integrity of our piles. So stay tuned for more insights in this next slide. So here it is. This is how it looks like. This is obviously a maximum 12 meter, and then based on the length of the pile, it can be what? Overlapped when it is inserted into the pile. Before we insert our reinforcement, we should check the length, the width, the diameter of the pile, and the center to center of our stirrup. The center to center of our stirrup and the total length of our pile. So then we can lift this and then insert it into our prepared borehole. And then after inserting it through our prepared borehole, the next step will be what? Pouring a concrete. So you can see these videos. about the operation of board pile. I thank you